Hi, it's time for another math easy solution. To discuss further into the Tengri 137 Odin's Triple Horn, and now look at a neat little calculator I made to help develop your own triple horn, and also go over an amazing MES custom MES Sigma symbol that I made, and it's actually way more advanced than the Tengri's triple horn from the info that I have gathered about it. So let's check it out. So basically, quickly recap the Tengri's Odin's Triple Horn. In my earlier videos, I went over the Tengri 137 cryptic online alien quote puzzle that people are thinking might be aliens or whatnot, or higher intelligence, and discussed the most perfect magic squares and how they are used to make the Odin's Triple Horn. So make sure to check out my earlier videos. I'll put the links in the description below. So recall that the Tengri Triple Horn Odin Horn are a group of 6 most perfect magic squares with a magic constant of 666, and then they contain numbers from 119 to 214 in series, and are grouped to look like the 3 drinking horns emblem of the Norse god Odin. And here's a link to the Tengri wikia.com page, and there is this cryptic series of writings, and then there's a triple horn, and everything is these are the 6 different Tengri squares, and they all add up 666 in almost every direction. Here's 666, etc. Go diagonal, it's 666, and other ways as well. So check my earlier videos to see that in more detail. And also recall from my earlier video on the visual representation of the Odin Triple Horn that I showed that the basis of the Odin's Triple Horn was symmetry of magic squares, something that is necessary for all the summations to add up to the same amount in any orientation or direction, etc. So what I did was, in my earlier video, I showed that starting from a distinct square A that I just got from Wikipedia, then adding 158 to everything, you get a perfect 666 square. This one is a 34 magic square, and then then all the other ones, Tengri 1 to 6, are just basically matrix transformations of them. So when you take these 7 squares, so the Tengri 6 plus my square, and then line them up in a table like this, starting from the lowest number, 159 is here, all the way to 174, what you notice is a pattern, and that is everything is split in 4s. Mine is a perfect in series from 159 to 174. Everything's in order, but you can still separate it into 4s like that. So 159 all the way to 162, and then Tengri 1, for example, here, this one's also split into 4s like that. 179 to 182 in series, that's in 4s like that. Yeah, so the minimum one is they're all in 4s. Mine's in 4s as well as complete total like that. And then when you graph these visually, what you'll see is that they're all symmetric about the center points. If this is 164, this is 165, this is 166. So this is right here 166, and this number is 167 like that. And as you can see, everything is symmetric. The MES one is mine, that's in the center right here, 16. All these other ones are just split in different symmetric formations. For example, this green one, that is the Tengri 5. So there's the green, there's the green, there's the green right here. And it's all perfectly symmetric about the center 166, 167 points. Yeah, so basically, thus, the Tengri Odin Triple Horn is simply 6 perfect magic squares that are symmetric about the center points 166 and 167, but all the numbers are in series, unique and without gaps. So as you can see here, when you graph all of these Tengri 1 to 6, it starts off from 119 all the way to 214, and every single number is filled out, and there's no duplicates. So that's what's cool about the Tengri Triple Horn. But since they're symmetric, this means that we can create our own version of the Odin Triple Horn by finding a different set of 6 perfect magic squares that are symmetric about the numbers 166 and 167, as well as being in series. So it doesn't need to follow these specific patterns. So what I did actually was I split these up into by 8. So what I did is, if we take this first one here and then move another pair like this, and then another pair like this, and then basically you can create your own your own Tengri Odin horn, and that's what I actually did. Yeah, so to prove this, I've created a Odin Triple Horn calculator, and I'll show you that in a bit. And I created the simplest version of the Odin Triple Horn. Here's the first custom MES Odin Triple Horn that I made. This yeah, I've only made one, but you can play around and see what you can find. So as you can see, this is yeah, 6 squares. Here's the MES Odin Triple Horn. This is number 1. This is 2. This is 3, and there's 4, 5, 6, etc. And then when you graph these, this one's just the basic MES square. That's a distinct A plus 158. And yeah, that's the same one as above here. That's exactly here, 159, 164, etc. And it goes to all the way to 174. 159 to this 164, 174 is the max. And then when you graph this from smallest to largest, you'll see 159 all the way to 174, like that. And you graph every single one, and then what you get is the square 2. Yeah, this square 2 right here. Again, this is a perfect 666 magic square, just like the Tengri ones. But you'll see the pattern here. This is number 2 goes 151 all the way to here. This is 158, and this one's 175 to 182 in series. So I have these all in pairs of 8s. So 2 pairs of 8s. Everything here is split down the middle, and as you can see when you graph these, you have, this is the MES square 1, and then you have these split into 2. So notice the pattern. This one is much more symmetric than, well, yeah, just much more simpler than the Tengri cube. So yeah, this is actually pretty cool. And now here I'll show you that calculator that I made. So here's distinct square A, and basically now what I did was, well, if you add whatever number you add, if you add 1 here, you'll get all you're going to do is add by 4. So that's going to be the magic square of yeah, 38 there. And as you can see here, these are all the calculations. This one is summation over there. I have a bunch of these, and this one's summation across like that. Let's see what this one is. Yeah, that's 4s. They all add up 666. If they were, yeah, I mean 34 in this case, but 666 in the Tengri cubes. So as you can see there, if you add any number, so every time you add 1 more to it, it increases the magic number by 4. So 38 goes to 42, added by 100. This is going to be, well, 34 plus, let's see what this is. Yeah, so 34 plus 400. 100 times 4 is 400, so 434. And let's go to 160. As you see, 164, 159, lower it. 670, and then we go 158. And there is our perfect 666, yeah, the mark of the beast square like that. Then also recall the amazing magic zero matrix that you could change these 3 and nothing else. And then these are all calculations based on this. So all you need is A, B, C. A is going to be negative A here. A, they notice the pattern here, like that. But for C, you have it. C is like this. B is across like that. And again, make sure to watch my earlier videos to learn more about this. And yeah, now if you change this number, and then what we're going to do is if you add to this matrix here, and also have this other matrix from my earlier videos as well to get, I'll show you what I'll do with that soon. But yeah, I'll show you the calculator. So then right now I'll just put 0, so all we're doing is looking at this square. So when we have that square, that's over here, everything's 666 calculation, and now I have this automatically ordered from size 159 to 174, and then I have graphed it here. So this is from this number 159 all the way to 174. Notice how it's just a perfect straight line of 16 numbers. What I'm going to do now is I'm going to scroll this up here. Yeah, and first off, just to recap, I'll show you how you can get, for example, Tengri square 1. All we need is these 3 numbers, negative 28, 34, 18. This is just a difference between the square that we're looking at, which is this one over here. So if we just add this numbers, let's see, this one is negative 28, 34, negative 18. So just to show you again, negative 28, 34, negative 18. So add this matrix. Notice the pattern. You get this one right here, and notice how this is split up into 4s. This is actually split up into 4s. Notice the pattern there. And then let's see, yeah, so that's Tengri square 1, and this is a different 0, 0. This is the exact same square like that. Yeah, in this part here, we could change this format axis just because it's automatic. Let's just change this to make it a bit easier to see. 120. So yeah, as you can see, there's 4 across like that. And now what I'll show you what we can do is if you pick, when I was playing around with this, if I picked a specific one, I'll just put 2, 2, 2, and you can play around to see what happens. But when you put 2, 2, 2, nothing actually changes in terms of, it's still going to be 1 to 16, but all this does is rearrange everything, and you're still going to be left with this 159 to 174 in perfect series, 16 numbers. But now if I put, let's say here, if I put 8, so what ends up happening, as you can see here, this gets split up. Let's go back to this, erase this. Yeah, so as you can see now, if I put 8, it splits up. So now we have this is in fact a perfect symmetric about the middle numbers 166 to 167. All we're doing is moving this across. Now if you put another 16, what happens here in this matrix? It moves this even further. Let's go with 24. Yeah, so we're moving by 4. So what happens is it moves it by 4. Let's go back to 0. So notice here, this one's 161. So we want to move this to the left. See what happens again. So 8. Yeah, so we're moving this by 8 all the way to the furthermost on the left. So yeah, so basically moving every single one of these points. So the lower end gets moved to the left, and then the higher end gets moved to the right by 8. Yeah, so now let's look at what we have here. So what we have now, and again, if you check the calculations, it's always going to remain 666. These are just zero-sum matrix, or these are magic constants of 0 that you could put whatever and nothing changes. So if you put 40, for example, this one goes all the way across like that. This is up to 120. But now what I'll do is I'll make this, I'll change this to reset back, so it chooses 0. Close this. I'm going to pick a really big number, let's say 140, etc. See how far back it is. This is almost near the 0, but this is still a perfect sum matrix. And then if you look at the numbers, you have 19, 20, 21, 22, 23, 24, 25, 26. That's 8 numbers. Then it goes to 307 all the way to 314. Now if we do this, just keep doing this using 8s, and then basically you can get 6 squares here. So what I've done is that exact same thing. So all these MES squares are made as follows: distinct A plus 158 to everything, then plus the 2220 matrix, then X times matrix 1. Again, the 222 is just this. You put these 2's inside, everything gets changed up like that. And then going back here, so I have MES square 1, 2, 3, 4, 5. This one is X is 0, so we're adding basically, this one's actually minus the 0 sum. Yeah, I just quickly updated that. So the first square, I didn't add this 2 2's 2. I just left it as is. Yeah, but you could add it. It still wouldn't change anything. All it will do is move these around, but it's still going to be from 159 to 174. So when you do this, you have 6 of these squares, and notice what we have is 6 squares like this. Yeah, when you plot them all, yeah, you get this shape. I don't know what's happening here. Let's move this around. See if we get the 6, 6. Yeah, so this legend actually goes to 20. I have some hidden, and yeah, here I just fixed that up. So this is actually up to 20, but just ignore the 7 to 20. Right now, that legend, for some reason, I can't hide these properly because I've actually made 20 total MES squares, but just ignore those. Just look at the 1 to 6. That's actually over here. So the 1 here is in the middle, then this 2 is just the same thing, but you split it down the middle and move it. This is from the 166, 167, move it across, and again you would split this, move it across, you have these double. This is 8, 8, there's the gray one, that's number 3, and then you move this across, and number 4 is over here, like that. So as you can see, all it is move the crosses 119 to all the way to 214, and everything is in order of size. The 6 from 119 all the way down the middle to 126, and then 207 all the way to 214. That's 4. I mean, that's going to be 8 total. Is 4 there, and then there's 4 there. So 8. All we're doing is separating everything by 8s down the middle. 8s, except the first one is, well, it's still separated by 8s, but it's a continuous 16. So from 159 all the way to 174. As you can see that pattern, and then basically there is my MES custom custom Odin Triple Horn. And yeah, you could put it like this, you could twist them and make it look exactly like that. So let's go back here. And yeah, so there, I just wanted to show that I can make my own Odin's Triple Horn that's following this pattern. But if you want a Tengri one, it does a weird pattern, but you could follow theirs, but still the same exact principle. And now here's where I alluded to that there was actually 20 in the legend, 20 squares, and in fact, we could take this to a whole new level once you understand it. So here's the sigma symbol, sigma like that. And basically we have it over here. So what I've done is, well, I've made 20 of these. These are 20 squares, perfect squares, and these are all 666 squares. And here it's shape of the giant sigma symbol like that. So there's all these are perfect squares. Yeah, so you can see that symbol. I made the sigma one like that for summation, because you know, for MES like that. So for a MES.fm, yeah, so go to my website, check out some calculators, etc. And now if you take this, so basically the sigma or summation symbol, and it's like that Greek symbol, capital letter Greek, and called sigma, I believe. Yeah, so it's made up of 20, not 21, 20 perfect 666 squares that all line up in series from 7 to 3263. 20 numbers, 320 numbers in total, all unique and in series. So here's again that original 1059 all the way to 174. We have those 6 ones I already went over, but then you can keep adding 8s to them. And again, I'll go back to here, over here. So this MES square is made where x is 6. We're adding, x is 8, so we add 8 to that matrix. This one is 16 times that matrix, and this is 40, etc. And then if you go over here, this one we can go all the way to 20, all the way down to 7, 8, 9, 10, all the way to 14. And then you can go to 21, but then you'll have a, well, -1 number. If you subtract by 8, you get to -1. And we don't want to deal with negative numbers. So you get all the way to there, and there's the highest one. So the 2 lowest, yeah, the 8 lowest numbers includes also the 8 highest numbers. Based on the symmetry, you graph these all together. You go from the center point, 166, 167, and there is the perfect symmetry. There's a 20 number over here and over here, which is pretty amazing. This is all in perfect series. So the way I made these squares, yeah, the way I made these squares, well, actually I just went over that, is by starting from the distinct square A and then adding 158, then adding a specific magic 0 matrix transform, then adding a multiple of simple matrix of the simple matrix transform. That was a matrix A. The larger the multiple of the simple matrix transform, the larger the separation from the center 166, 167 numbers. And here's just a quick example. I've already went over this one, but you have square A plus 158, you get our 666. Then what we do is we add this 222 plus this 8 times matrix 1, and then we separate this by 8 across here from the center of 166 is actually somewhere over there, and 67. So there's a separation, and there's the perfect symmetry about this point like that. Yeah, so let's go here, and I'll show you those giant squares. So what I did, I've hidden over here. So let's highlight this, click unhide. So when we unhide, then there you go. We have even more squares like that, all the way to 21 across here. I'm just going to erase this. And this one is x is 160. Then we have, this one is 21 actually. Yeah, so as you can see, it goes to the -1, etc. And this one is all the way to 20. We have 7 the lowest. There's x is 152. And again, what we could do is unhide these. Unhide. So we unhide this, and there's a count. You could count the total as 320. That's ignoring this one, I believe. Let's click this. Yeah. So that's ignoring this one. But as you can see, that if you go to negative that 21 square, you have -1, 0, 1, 2, 3, 4. But it's this. So just so you can keep going on. And there is there is everything in perfect series. This is 119. I'm just gonna go to format axis reset, so it goes to 0. Yeah. So as you can see, this is a perfect in series from 7 all the way to 7326. 7326. This is unreal. And yeah, there's that Odin Triple Horn MES one. MES horn. But now if you go over here, and there is our Sigma. So as you can see, put these. You can just put these random in there, and then you hover this over. It's a Sigma symbol like that, and these are just those squares. Yeah. So there. That's this is 20 perfect magic squares, which is pretty cool. So, and then basically, yeah, to make specific Odin Triple Horn, your own specific one, you could just play around with the matrix transforms to get the exact squares they used. But the basic idea, yeah, to make the specific one, but the basic idea is the same. Symmetry about the middle points, 166, 167. So you can make your own one if you want, or you can make their specific one, as I went over my earlier videos, so check those out. And also I want to make a note, my analysis is based on the assumption that there isn't anything special about the specific numbers Tengri use, and I assume there isn't any overall connection between all the numbers, besides being just in series. If you find something particularly special, such as a possible 3D service created from those numbers, so yeah, please let me know if you do, and then I'll reevaluate my video, see what other stuff they have. And also, to answer a question I had in my previous video on the visual representation of the Odin Triple Horn, the 3 distinct squares can be formed out of any other distinct square using just matrix transform. Remember, there was 3 distinct ones. There's A, B, C. But now if you look at the difference between, well, this one's this minus this, what we could do here is an example. If we take the square A, throw this inside our matrix transform, all we do is just add 0 here. We don't affect that. But then look at this amazing magic 0 matrix. All we do is add this -2 there. So A, B are 0, C is -2. What we get is this number, which is still 1, 2, 3, 4, all the way to 16. It's still a perfect 34 magic square. But now this one, we have 1, 8, 11, 14. This is exactly this one here, 12, 13, 2, 7, 12, 13, 2, 7. So what we have is this. So see the loop? We went from distinct square A, added this matrix transform, got distinct square C. So basically the words distinct just means the lowest way you can write them. Yeah, besides that, it just means that you could rearrange these in another specific way and still get the perfect magic square. And it's distinct, meaning if you rotate it, doesn't count. You could just rotate this 360. That doesn't count. And also, I will look into researching some of the other very interesting calculations in the Tengri 137 puzzle, so stay tuned. Because, yeah, it's some pretty advanced mathematics, and it's very cool. And whoever made them was really into the mathematics. They might have even had a team of mathematicians working on this together and trying to get some correlations from historic biblical references and other kinds of references. But it's pretty cool nonetheless. And then this Odin's Triple Horn, again, it's understanding of the symmetry of it. And here's the one I made from all the way to 7 to 326. And there is my perfect sigma MES summation symbol of 20 of these perfect squares. And yeah, there's the MES out of FEM logo like that. And there's my own custom MES Odin Triple Horn. And it's, again, following the same simple symmetry, separate everything in pairs of 8s, etc. And Tengri's was a bit different. They separate them in 4s, some of them in 8s right here. That's 8 for this Tengri 4. Some of them are in 4. Most of them are in 4s. But then this one here, you have it in 8s in the center. Then you have 4 at the edges for Tengri 6. So again, but they're still symmetric about the center, 166, 167 points. So yeah, that's all for today, and I'll check out some more calculations on Tengri puzzle, but I think I'm done for the Odin Triple Horn for now, unless you can find out anything else about it, like some 3D surface where they're all connected somehow. Anyways, thanks for watching, and like always, you can download these exact notes in the link below, as well as the Excel sheet that I made in the link below. Thanks for watching, and stay tuned for another Math Easy solution.